In this video, I'm going to talk about there's two types of matter we already talked about, or two types of mixtures we already talked about. One's a heterogeneous mixture, the other one's a homogeneous mixture. Now we're going to focus on the homogeneous mixture for the purposes of this PowerPoint, because there's those are typically called a solution, which I'll get into in a second. Once again, just to remind you, heterogeneous, hetero meaning different, homo meaning the same or similar. So it says a homogeneous mixture cannot be distinguished. The parts cannot be distinguished from each other. They're evenly distributed throughout. Think of salt water, think of gold, or excuse me, not gold, jeez, I saw that. It says 10 karat gold, meaning there's a mix. It just has some gold in it, but there's a mix of other things. But it all looks like it's gold. It looks like it's pure gold, but it's not. Air, etc. We already talked about this. Now a mixture can sometimes be called, I don't like that that's black, let's try this. A mixture can be called a solution. A homogeneous mixture can be called a solution. Separate particles are not visible when one dissolves into the other. Alright, and so there's parts of a solution that we have to go over. Now my thing got kind of mixed up. There's two parts of a solution that make up a solution. One is called the solute. Alright, the solute is typically the substance that is being dissolved. A better way to look at it, it's the one of the smaller quantity. So like if I have salt and I have water, well obviously if I have salt water, the state of matter it's in, it's water. And so I've got obviously more water than I have salt that's mixed in. And so even though it all looks like one substance, it's two separate substances. It's salt mixed in water. The solute, the substance I have less of, is going to be salt, because what I'm left with is the water. So typically whatever substance you have the most of, the larger quantity of, is going to be then called your solvent. Now water is pretty much a universal solvent. Water is used very frequently whenever dissolving things. Water is, we might get into this a little bit, it's not really in our standards, but it's called a polar molecule. It's a very good solvent. A lot of things dissolve in water. So water is typically going to be a solvent. If water is part of the equation, it's typically going to be a solvent, because water does dissolve several things. And so the substance, the two parts of a solution, the solute, the substance getting dissolved, the smaller quantity, the solvent is the substance that is doing the dissolving, the larger quantity that dissolves the other substance. And so, and like I said, there's reasons why there's attractive forces. The water has a slightly negative and slightly positive end of the water molecule. We'll dive into that more when we talk about compounds. I don't really want to get into it a ton. You're just going to have to trust me. All right, some other terms that we'll use, things like solubility. Solubility is the maximum amount. I'm going to highlight this bad boy. I don't really like, I'm going to change the, make it gray maybe. Can I make it like a light gray? It kind of darkens it. But anyway, is the maximum amount of solute that can be dissolved in a given amount of solvent at a specific temperature. Alright, so solubility is how much solute, the smaller amount, if I'm talking about salt and water or sugar and water, the solute is the salt or the sugar, can be mixed into water at a given temperature. When water is at a given temperature, we're going to look at how temperature affects solubility, because as you change temperature, you can mix in more. You can mix in more solute as the temperature increases, and we'll explain why in a little bit. Every chemical substance which dissolves in water has a fixed solubility, meaning there's a set amount that you can mix in at given temperatures that won't change. So if you try one time and you mix in, say, 100 grams of water, when water's 50 degrees, you mix in 10 grams of Kool-Aid. Well, that'll never change. That has a fixed amount at a given temperature. Each substance has a fixed amount. If it doesn't dissolve, the solubility then is 0. We'll talk some of the solubility graphs. I don't think we're going to do that. We did that last year. I don't think we're going to do it this year. Some of the terminology that you have to know. There's terms so you have to know solution, you have to know solute, the smaller amount, solvent, the substance that is doing the dissolving. The other way you can think of it is the substance that's more, well, solvent's a bigger word, and so it has a bigger quantity. Solute is a smaller word, it has a smaller quantity, so that might help you remember. I don't know, but hopefully it does. I gotta find where I was at, sorry. Other terms that you're gonna need to know, things like saturated. Saturated means you can't mix in anymore. The maximum amount of solute, the substance being dissolved, that can be mixed in. So if you have a saturated solution, that means you can't put in any more of a substance to mix in. You can't put in any more solute to get dissolved. If it's unsaturated, that means you have less than the maximum amount. That means you can mix in more because it's not fully saturated. Supersaturated, that's pretty rare. It's when more than the maximum amount. That involves like heating up a temperature. I'm like gouging my eye on the video. Heating up a temperature substance to a high temperature, adding in solute, and then rapidly cooling it. That's pretty rare. Diluted means it's less concentrated. It's less concentrated. If something is concentrated, then it obviously has more. And we're going to do a solutions lab. Depends when we watch this. One of these days, where we look at how temperature affects an M&M. All right, we're going to dissolve an M&M in water. We're going to use cold, medium, and hot water, and we're going to dissolve. We're going to see how temperature affects the solubility of those. All right, so that's what we need to know about solutions. Those terms are going to be important. We'll be going over those, just using the verbiage. And when I say solvent and solute, I wanted you to know exactly what I was talking about.